Hey, my name is Megan. I work for KMW Technology as a project manager. KMW, we've been in the business since 2010. We're a search professional services company, so we do consulting and we also help build solutions. We like to think of ourselves as having a very strong presence in the open search community. We really specialize in Solar, Elasticsearch, OpenSearch, and now Swirl. And going with that passion, we develop a lot of open source projects that we hope others can use. And one of our open search projects is something we call Spyglass. Spyglass was originally conceived by us as a simple UI to display results from Solar. It's built in Angular. We use Bootstrap and Node.js. And the basic idea is that we display a UI. It's driven by components that are defined in a JSON file. The UI is composed of components that configured to your search instance. So you can offer a lot of specialization in this area. We can return search results as hyperlinks. You can define your facets, your aggregation. You can label your fields. Control what fields are coming back. You can control your results and your view of those results. The idea here is just to offer a lot of flexibility in what is shown in the UI.
Let me just flip back and forth a little bit here. So for example, I'll do a new search for knowledge management, one of my favorite topics.
I would say some of the interesting challenges of doing federated search is when you think about things like faceting. If you're not getting all of your results back from one search engine, sometimes it can be hard to know what's coming back. But one easy option here is to allow the ability to facet your results based on your search provider. So we implemented that as a first pass. Another interesting question is how to sort your results. There's a swirl, obviously, result that is being calculated, but we looked at other ways to do it by leveraging some of the result mixers that Swirl offers.
Right.
So we offer those.
That's up here. So thank you, Megan, for that. The one of the key points about Swirl is we land the results in our internal data store, and we then use mixers to serve up the results. And by default, of course, we do rank everything by relevancy. However, we might want to take a look at other views of the data. For example, show me a kind of cross section of the data. So rather than sorting it by relevancy per se, where, for example, for this search, enterprise search might be a little bit more dominant, putting two results here in the top result of the result set. If I go to a round robin mixer, it's just going to take one and then continue to the next source. So essentially, they're kind of like it's showcasing all the results while still roughly keeping relevancy order. That's one example here. And then we also have the date mixer control, which is wired in now, and that will show us only date sorted material.
Sid, while you're on this page, one thing I'll also mention is you might be wondering why we keep talking about a card view versus a table view. Our card view just offers a lot more real estate. What this offers is the ability to include in the search result a payload, which gives you a lot of extra data. So as you are pulling in many different results from many different sources and the information could vary a little bit, this card view offers you a lot of real estate to kind of display some extra information that could be helpful to your users. Otherwise, you can kind of switch back to the table view and kind of get like a more streamlined view that's a little bit easier to process, maybe a little bit less information and real estate there, but we offer the two options.
Thank you for actually highlighting the payload. So if we go, and actually what I'm going to do now is jump back and take a look at the search result object that we just created through Spyglass. I'm going to pull up the result list here. This is a result from the Google PSE. And as you can see, the title, body, URL, date published, author, these are the traditional schema fields for search. And that's what Swirl comes really pre-configured with. But there is this payload field. And the payload field is intended to hold other information in it, arbitrary information. So I'm going to actually just scroll for another second here until I grab a Northern Light Research result. So if I just look at NL Research's results, we will see for every one of their results, there is this payload, and they include, we've selected via the search provider to grab the type, source, country, and language elements of their response. And this can be varied from response to response and from service to service. So think of the payload as the place to put any additional data. And exactly as you pointed out, it's kind of cool to display it this way. This data, even though it's specific to this result, can still be viewed and accessed in the search context. So Megan, tell us a little bit about how this stuff works. I'm going to move to your next slide.
As we mentioned before, our UI is basically composed of components. This is all in Angular. Everything that's in purple is our Angular, is happening within Angular. But we also have a service layer. So what happens is our query comes from the UI within our service layer, which holds our configuration. We are able to form a search request that goes to whatever backend. So originally we just had this for Solar, but obviously a big chunk of our work here was to extend that so that we could talk to Swirl's backend and issue a search request and get a search response. Additionally, Spyglass really relies on the concept of observables, the RxJX library from Angular, which is reactive extensions for JavaScript, allows us to assign observables or events to whenever a search request is coming back, whenever a search response is coming back. And within our service layer, we basically update those observables as new events. And our UI is just kind of listening in on those observables. So what's kind of cool about this design is that the UI is never directly talking to your backend. So it makes it like a very pluggable framework right now. Again, it works for Solar and for Swirl, but easily adapted to other search engines. And yeah, we think it's just like a nice, easy way to maintain things. We offer a lot of different configuration options and different ways to sort of customize this within that. It's very flexible. I'll just call it some key things we did for Spyglass, which is, extending that, adding facets, adding our sort options, and just some general UI polish, added hit highlighting, for example. And as Sid mentioned, it's included in the Swirl 1.10.
Yes, I was just going to show actually. So we've even wired it up. So here from the Swirl homepage, hopefully you can see the Swirl homepage. You can actually go straight into to Spyglass. So it's fully integrated and served up by the same container. So we're super excited about it, and we definitely want you to check that out. Meghan, tell us a little bit about KMW and what you guys do.
So as I mentioned before, we're a search and AI professional services firm. So we do consulting, and we also build new solutions. But really, at the end of the day, we're interested in helping make your search better. So we do a lot of package services, which are all based around improving your existing search. So offer different ways to build new search solutions. And we contribute a lot to open source projects. I'll just say really quickly, Swirl does use OpenSearch, Solar, Elasticsearch. And when you're doing federated search, sometimes you can have different bottlenecks from different search engines. So speed or performance is any issue with any of your search solutions that you're bringing into Swirl, we're always happy to help. A great tool we have is Lucille, which is an ETL tool that helps index your data a little bit faster and easier and more painlessly.
Good for prepping your data.
Access anytime.
Absolutely. Thank you very much. I actually want to go back. So thank you so much, Meghan, for sharing this stuff with us. And we're super excited about having it in the release. And I want to talk for 1 second about query adaptation. So I'm going to run one of my favorite queries, Elon Musk, not Twitter. I mentioned earlier in the query mappings under a search provider, one of the capabilities that Swirl has is to say, does a search engine have the ability to handle knots, for example? And if not, no pun intended, Swirl's adaptive query processor will rewrite the query and make it so that it works for them. Here, for example, and people often don't believe me when I say the Google PSE doesn't actually support knots. But what you'll see here are high quality results, and I'll go ahead and switch those into card mode. You will not see any mentions of Twitter here because we have actually rewritten the query we sent to Google PSE to, instead of the term that I used here, not Twitter, we rewrote the query to minus Twitter. And we can actually verify that by going and looking at the search object. So here's my query. And if I open up the result list, you can see here the adaptive query processor rewriting the search to Elon Musk minus Twitter. The reason, just to be clear, I often people say, no, Google supports not. It actually does not support it. not to negate a not, but for the Google PSE, you have to put minus in front of the term. So that's an example of query adaptation at work. So to summarize, Swirl has a range of features for meta search that lets you interact with, query vast numbers of sources, anything with a search API that you can reach. It operates asynchronously, includes processing pipelines for things like query adaptation and also for processing results and relevancy ranking them. It includes duplicate detection, the ability to filter results by a source, even a subscribe mode. So once you've set up a search object, if you add the subscribe property and set it to true. Swirl will update your search every so often and basically make new results available through the same endpoint. Along with the expiration service, it can be used for a range of different kinds of applications in the enterprise and solving numerous different problems like one search box to rule them all, or whether you're doing machine learning and AI applications, building push systems, or predictive information delivery. Swirl is designed to make it all happen without moving the data. And I think that's really changes the effort level, right, and how you would consider a particular project, even if you would do it at all. So with that quick summary, just to bookend the Swirl demo, I want to go a little bit deeper now and introduce Dave Nicodemus. Dave is going to show us version 110 actually receiving feedback from queries rewritten queries in OpenSearch, I think. Is that right, Dave?
Correct.
What do you do over at Swirl?
So I'm a developer at Swirl Inc. So I work on a number of projects. Been with the company for a couple of months now. What we're going to talk a little bit about is how you can use QueryGui with Swirl and how we receive feedback about which terms were hit on which documents and how that's incorporated into the relevance ranking that Swirl provides for federated search. QueryGui is a pretty powerful query rewriting tool available in OpenSearch, Elasticsearch, and Solr. My environment is configured with OpenSearch. This isn't really a demo about QueryGui per se, but we'll look quickly at what my environment is set up like, and then we'll add some synonyms to QueryGui. We'll configure Swirl to query that OpenSearch provider, and then we'll show it extracting synonyms from returned response from OpenSearch. So first off, setting up OpenSearch, very straightforward. You can see my Docker file here, basically just starting off with the OpenSearch 2.30 image, and the only really change that you need to do is run the OpenSearch plugin installer and point it to the right version of QueryGui. So you've got 2.30. With OpenSearch plugins, the plugin version numbers need to match the OpenSearch version number, which I think most people are familiar with, but worth noting here. Then we just run this Docker image locally, and you've got OpenSearch running with QueryGui. The only other sort of thing worth noting here is the data that I loaded. Maybe you noticed from my directory here is I loaded the Enron email data just for the purposes of this demo, and we use it a lot internally to sort of test things, or I do anyway. Let's now take a look at how you add synonyms to QueryGui. So I've got this sort of in a shell script, but we'll take a look at the shell script quickly. So this is all wrapping around a curl call using a REST API. So QueryGui is configured with a REST API where you basically tell it which of its 4 rewrite classes that you want to configure and what the configuration is. They have a very rich set of configuration options. We're going to just do something simple here for purposes of demonstration. So we are configuring the simple rewrite simple rewriter with a couple of synonyms here. We'll do personal computer to PC, PC to personal computer, a couple of other ones at the end just to sort of fill things out. And we'll just run this script now. And we got a 200 back, which shows that we succeeded. And because this is OpenSearch and everything is an index, you can just look at the content of the query configuration and see by looking at the OpenSearch QueryGui index that we indeed have the rules that we just set up. So that looks good. And we can also do a quick demo quick query outside of Swirl to just show this working. So let's, again, we have a script, but we'll look at the script for a sec. Search dash demo. Right, so again, all window dressing around curl, and we see that this is a OpenSearch query. It's got 2 things that are worth noting. One is a highlighting section. That's important actually to Swirl, and we'll talk about why later. And you've got a QueryGui section, which is just important for QueryGui, of course, and it shows us basically using the common rules rewriter that we just configured and give some boost to a couple of the fields. So a 3 from subject, 2 for 2, and content no boost, just one of the query fields. So yep, we can now run this script. Oh, sorry, one quick thing here. And you see here that we replace the query with the script parameters. So we can now search for personal computer. Probably gotta say which script we really want, right? And we can see that, again, this is all query output, sorry, all open search output that we got hits on PC, even though we searched for personal computer, and that just shows that the synonyms are actually working. So we're sort of ready to start accessing this from Swirl. So now we'll come over here and go to a Swirl directory that I already have cloned, and we'll start we'll do the setup from the beginning here because it doesn't take long. So we run our install script. And then we'll run the setup. This is just doing migrations. Anyone who's familiar with Django will sort of understand some of this output.
This is a typical Swirl startup right here.
Well, this is the, yeah, right, exactly. Exactly. And now we'll actually start. Okay, so I'm going to start the core. I start core because I only really need to start Django and Celery. I have Rabbit running on my machine all the time, so there's no reason to have Swirl start that. So now Swirl is starting. We'll just wait till it finishes. All right, very good. And now we should be able to go to local host. And we can. And the first thing I always do is log in, because you have to log in. Great. Okay, and now we'll go to search providers. So, that's all like very straightforward, very easy. So here's all the search providers that Sid was talking about. These are all come preloaded and pre-configured with everything, but of course, authentication info. So what I'm going to do is add a new one, and I'll show sort of how easy it is to add a new one while I'm doing that. And also just a clean slate so we can run some tests. So let's see. Okay, so let's just create this first, then we'll talk about it. Okay, so I just created a new search provider, so that's pretty easy. Now I cooked up the JSON ahead of time, but there's lots of examples to choose from. I think things that are worth noting here is that the query is really just the same query that we were looking at earlier from that script, with the exception that the query that gets substituted now comes from a query string substitution parameter that Swirl manages. And the other two pieces that are important, it's really one piece with two sub pieces, is we tell Swirl where to find the highlighted content that comes back from this provider. And this is configurable because it's going to change both per provider and per schema. So in this case, we tell it that the body hit highlights come from the content field and the title hit come from the subject field. So this lets us know where the synonyms are going to come back from when we do a search. So we've done that. So now let's do a search. Let me see if I can find my world here. Right.
Just to do a little commentary, that what you just did there is essentially a mapping, right? So you're pulling out, you're declaring where you're going to get that from, and then you're identifying where to pull the highlights from exactly in the mapping.
Right. So this is basically going to come back. This is pulling data from the search provider's JSON structure, and we're just telling Swirl what that structure looks like so it can find the content. It's a mapping, just as it said.
Exactly.
So we're going to do no worries. So we're going to do a notebook, a query for term notebook. So let's just stick with the Enron. So you can see we got our Enron data here. Let's see, the Enron time. Where is it? Was 0.4 seconds, which is pretty fast. We only got 381 results from that, and that's because basically notebook doesn't occur that very too often in this data set. So now let's go add another synonym. Let's go add a synonym for it in Query. So we got a script for that, but I'll just cat that, and then we'll have a look. Demo-2, and we're going to run this script. Okay, so now we updated those results, the query configuration, and now we can see the query configuration there. So now we have a synonym notebook for laptop. And now we'll do the same search. As you can see, we got a lot more results back, like 1,000, so about 3 times times as many. Looking at the info you get back from each provider, we can see that the terms that were the term that was pulled out of the provider's data structure was laptop, and we can see that we've got a number of good hits now from Enron for laptop in the subject, in the body, multiple times, or once here, but multiple times in these other ones. And we got our results were scored correctly, and the notebook term was scored correctly in the title and in the body when it's there. So, I mean, that's essentially it.
First of all, Dave, thank you for that. So I think the key point is this. When Swirl is meta searching across multiple sources, each of those sources has its own view of the world, its own business logic, taxonomies, ontologies, and absolutely synonyms, acronyms, all kinds of query transformations. And the key, what we've really done in 110, and Dave was far too modest to describe himself as a developer when you're the head of technology here. What we've added in 110 is receiving or detecting that business logic in the form of highlighted new query terms, adding those to not only to Swirl's highlighting, but also to the relevancy model, so that we really essentially Swirl learns, right, the variations. And in future versions, today we restrict the use of those variations to the source that reported them. But in the future, the fact that one silo said, well, you searched for laptop, but you maybe really meant notebook or tablet, that is the idea where we could potentially share that data with other sources too, and perhaps improve the results across the field. So that's just one example, but I want to just emphasize this is a very powerful capability, and not just a mapping. It's really much more about collecting that feedback. So a question about Query as a rewriting framework.
So the question is, I just want to read it aloud for the webinar.
Please do.
Renee asks, as Query is a general rewriting framework, would you see a case for using Query for creating queries / adding synonyms for further search engines?
I would just say this. I think Query is used heavily in the open source community for rewriting, and particularly for e-commerce, but for other applications as well. I think it would be great if other search engines, particularly the commercial ones, would start to support it. What do you think, Dave?
Yeah, no, I think that's right. It's something. It's a very powerful tool. It's something of a black box. It's only accessible through its REST API, although the configuration is accessible to the REST API as well. So certainly the synonyms are available for use in potentially other sources, but beyond that, I think some work would need to be done to use it for other purposes.
I think that when you're talking about meta search, we are very much focused on the query. You saw an example of how the adaptive query processor rewrites the query to optimize it for each of the receiving search engines. I think that in the future, you will see the ability to manage some of the query transformations on the Swirl side. So for example, if there's business logic that you would today want to pass down to other engines, that's something you could add now into our query pipeline. But in the future, that it could be something that we automate the process of. So I think it's a very exciting idea, and that's what meta search is all about: understanding the query and finding everything that everything else knows about it.
Renee had a follow-up asking, he was just saying he was thinking of the not case and how Query could be used there.
That's a really interesting idea. I don't know if Query supports the notion of the provider's capabilities, but it might be something where we could help it with that, actually. Maybe that's a very interesting idea. Dave, what do you think on that?
Yeah, it certainly, so it certainly has the capability to do that, but again, surfacing that capability for other engines seems like it would be more trouble than it would be worth. As far as handling the not, I think that there's other rewriting. For instance, the adaptive query processor handles it in some way, and we're working on features in the future to do rewriting sort of internally in Swirl that could handle that as well. But I think that handling the not rewrite is sort of something that certainly that it's a one aspect of what Query could do, but I think trying to use it to work with other engines would be probably not worth the effort right now.
We're always looking at it, and I'd love to hear if you, Renee, if you have a particular case or example where you think would be interesting. In the meantime, you can definitely use the adaptive query processor with any endpoint that we talk to now.
And we're clearly really excited about the the 110 product. And I see, Sid, you've brought in Renee, who was asking the question. Renee, if you want to join the conversation here.
Please
Yeah,
do.
thank you. So I have to admit, I'm the creator of Quirky, so that's why I asked those questions.
Cool.
So,
Oh,
Familiar?
wonderful.
I wanted to know how it's being used, and I really liked the ease of the integration as it seemed. So, but if you think about the design of Quirky, it has a core that is entirely search engine independent. So that means it has an object model and can express things like not and so on. And the object model represents the query. So I was thinking, in the end, you get a query string and then transform this query string into search engine specific query. So you might be able to use that object model. So that was a bit the background of this question.
Yeah, so that's interesting. I looked into this a little bit. It seemed that, well, so there's a lot of practical issues there. Like right now, the infrastructure that we have is mostly Python based. And I looked to me like, I know that I've looked at the Quirky core code. I think it's all Java, right?
Yes, it is. Yeah.
Yeah. So but that's not alone an impediment necessarily, but it's like more maybe a speed bump. Certainly, it's still doable.
Yeah.
It
You
definitely
might-
has some possibilities. Yeah.
Might be easier if you just use the means that you're currently using. I mean, the not transformation is not a big thing probably. But on the other hand, we found it quite useful to have this chain of rewriters and the pluggability of rewriters. So that comes to mind if you think, okay, I want to transform queries again and again. Yeah.
Awesome. Well, look, I think we've hit the top of the hour, so we do have to wrap up. But let's have that discussion offline. I think it's a super interesting one. That was really where we started when we first did this, right? Is that we should adopt this as a working way of modeling this capability. And yeah, let's talk about what we could do next.
Yeah, and Renee, we'd love to have you on another session as well. So it's a wonderful surprise to have you join, and it's just so perfect for our packaging with Quergy as well.
Yeah, sure. So let's talk. Okay.
Yeah. Thank you very much.
Thank you. Listen, I think we'll thank everybody so much for coming. Really appreciate the time. I'd like to thank Meghan very much from KMW. We're super excited about Spyglass. And we'll have lots more to show in 2 weeks at the next one. Thank you very much for coming. Please don't hesitate. Visit swirl.today or join our Slack if you want to participate. We're always welcoming to anyone who wants help or to contribute ideas. Thank you.